Hey there, physics. Mrs. Kozian here, and hi. Haven't seen you guys in a while, and I'm just recording here to kind of get you guys ready for what you're going to be moving on with Thursday and Friday. First of all, hopefully, if everything goes as planned, I should be back on Monday. And thanks for working so hard for your substitute and fourth hour for Miss Kuipers. Okay, so keep working hard over the next couple of days, you guys, and we will get caught up. So let me talk to you guys today about displacement versus time graphs, which is what you guys were just looking at in the constant velocity worksheet, number 3 that you were looking at, and also in that motion detector that you guys did with Kuipers or with the substitute yesterday, okay? So first, let me start with your skills checklist in the front of your packet. So right now, if you don't have this in front of you, I want you to have this open, okay? And let's walk through what you do know. You guys know how to do most of this stuff already, okay? Calculating speed, distance, and time, you know how to do that. You guys just had a quiz over that on Tuesday. Describing difference between scalar and vector, done with that. Examples of scalar and vector, done with that, okay? These ones about velocity graphs, these are ones that we are going to be working on hopefully starting Friday and moving into Monday, okay? So reading velocity graphs, describing what's happening, reading velocity graphs, describing where acceleration's happening, transferring displacement to a velocity graph, okay? You guys are going to start working on this stuff Friday. We're going to finish up Monday, okay? This is the big one I want to focus on today, okay? Reading a displacement graph, describing the motion that's happening. You guys already know difference between displacement and distance. You guys know how to draw dot diagrams from the reading guide that you did in class on Thursday. And last one, talking about next week, we're going to calculate acceleration. So ones we don't know how to do just yet are the velocity graph ones and the acceleration ones, okay? Today, really focusing on the displacement graphs. And you may have seen them called position graphs, or they may have been called distance graphs. We're going to try to focus on them being called displacement or position graphs from here on out, okay? There's a couple great examples in your packet. Remember, you guys, the difference between displacement and distance. Distance is how far we went. Displacement is how far we are from the beginning, okay? From where we started, okay? So distance is almost always going to be positive. Displacement can sometimes be negative, okay? We can go back past where we started, okay? So student, here's the distance that he walked to school, okay? His displacement from home to school is positive. But if I go back past home and go in the negative, we can have a negative displacement. Okay, so that's going to help you out with what we're talking about today. Okay, let's see, just kind of scrolling through your packet here. Go ahead, you guys, and turn to page 5. This is just a review of some of the motion detector stuff you guys did yesterday. Okay, this first column right here, over here is the descriptor of the motion. Over here, this describes what you guys would have seen in the motion detector graphs, okay? This velocity versus time one is what we're going to start looking at, hopefully in class Friday and finish up Monday, okay? So this is the one we're looking at, position versus time or displacement versus time, okay? When your object is not moving at all, okay, your position stays exactly the same over time, okay? So this graph is probably showing where something had moved maybe like a few meters away from the motion detector and then stopped moving, okay? Moving forward at a constant velocity, you guys, shows a constant slope, okay? The steeper the slope is, the faster they're going, okay? So if this line were moving out like this, okay, if this line were moving out with not such a steep slope, it would still be a constant velocity. It would just be a slower velocity, okay? They're going much slower. If you've got a super steep slope going up like this, you're going really fast, but it's still constant, okay? Now, an object moving backward at a constant velocity. This doesn't mean that you're walking backward, okay? It means that you're going back toward where you came from, okay? So we start maybe this far away from our origin. Down here would be where our origin is, okay? So we can have a negative position, okay? We can have negative displacement. I could go below this x-axis if I really had to, okay? Negative position, okay? The steeper this is, the faster you're moving back towards where you came from, okay? This one shows the differences between those slopes, okay? A is an object that's moving slowly. B is an object that's moving really fast, okay? They started at the same place, Okay. But B is way farther ahead because B is moving faster. Okay. And then changes in velocity are shown with curves. Okay. We won't get to that till we do acceleration, which will be later in the day, Monday or Tuesday. Okay. So this is really what I want you guys to focus on today. I want you guys to be able to look at a graph and tell me what's happening. Okay. If it's straight, it's not moving. Okay. If it's moving upward with positive displacement, it's moving away from where it started. Steeper it is, faster it's moving away. You see the line pointing down, you're going back toward where you came from. Okay. Steeper line means faster. Okay. Next page, you guys turn to page 6. Okay. The first graph, ignore this first graph. Okay. We'll start talking about that Friday. Okay. Second graph is just another representation of that distance displacement thing for you. Okay. You guys can see right here, we just have one motion here, steady, really, really, really fast speed, distance or displacement or position. All those graphs mean the same thing to us right now. Okay. So right here on page 6, you guys really super fast, but a steady velocity. Okay. And then this line, okay, is moving at the same time, but a much slower velocity. Okay. But they started in the same place. Then whatever this object is doing, okay, this one's moving with a steady velocity till it reaches the 10 meters. This one moves a really slow velocity, then stops moving for a while, okay, then goes all the way back to where it started from. Okay, so one explanation for this could be, like, let's say that you're running around the track or something, okay? You guys know usually one round around the track is like 400 meters, about a quarter of a mile. Okay, so let's say this person ran a pretty steady pace until they got, like 3/4 of the way around the track. Then they stopped and took a breath, and then they ran the other part of then they ran the other half back to where they started from. Okay, this would be a good explanation for that. If you wanted to do it with my ugly dog, okay, my husband walking my ugly dog Gus. I know we've used this one before. Okay, this could be my husband running down the street with my ugly dog Gus. Okay, and then stopping to take a breather, stopping so that Gus can go to the bathroom on that tree that you guys know he loves to go on, and then running all the way back home. Okay, came right back to where he started from. Okay, so that's our distance versus time graphs. Okay, or displacement or position. Remember, they all mean the same thing. Okay, one thing to kind of get you guys moving in the idea that you're going to see tomorrow. Okay. This is a steady velocity. This is all the same velocity. Okay. Steady, consistent velocity. Okay. No velocity whatsoever because we stopped moving. Steady, consistent velocity. Okay. Your job tomorrow is going to be for you to get to the point where you can take this graph and turn it into a graph like this. Okay. Velocity graphs are very different from displacement or distance or position graphs. And it's tricky taking this and turning it into this, okay? But the one big thing for you to remember and take away from today is anytime you've got a straight line here, you have a steady velocity, okay? This is a steady positive velocity, no velocity whatsoever because you're not moving. Steady negative velocity, okay? Because we're having a negative displacement. We're moving back to where we started from. Steady positive velocity, no velocity, steady negative velocity. Okay, so kind of hold that in your head for what we're going to be talking about tomorrow. Okay, other things that you guys have done. This next page 7, page 8, we are going to be doing when we talk about acceleration. And this is one of the things we're going to be doing when we're making those velocity graphs starting Friday, Monday. Okay, kind of working my way through 9, 10, constant velocity worksheet 3. Hopefully, you guys already got a chance to go over this with either Ms. Kuipers or the sub. I know you guys did this in class on Thursday. So hopefully page 11, page 12, and page 13, you guys already went over. Constant velocity worksheet 4, you got to know what we're doing Friday to do that one. So skip that stuff. Okay. And then motion review, you're going to be working on Friday. So today, you guys will hopefully be going over, hopefully before you even talk to me, you went through 10, 11, and 12, sorry, I'm getting mixed up, 11, 12, and 13. Then you listen to me just review displacement, and now you guys are going to go and finish your graphing challenge, okay? Finish it today. You got no more time in class to finish it. We got to move on to something new tomorrow, okay? Be good. See you guys soon. Thank you.